Welcome. This is part 12 about the Olshammar engine. Here we simulate a diesel engine, a 4-stroke diesel with 3 cylinders, and it's done together with FEV Sverige AB, a part of FEV Group from Germany. We simulate this diesel engine and we compare baseline engine with 3 cylinders only with the Olshammar engine that has an added exhaust piston as well with regards to brake-specific fuel consumption and brake power, and the simulation is done at 1800 RPM. Here we have the baseline engine, and you can see the 3 cylinders. And here below in the red text you have the model files that you can import yourself from olshammar.com website. So if you have access to GT Power, you could verify these results yourself. And here are the parameters that we are optimizing in GT Power. And here we can see that the red curve is the pressure, and it has reached the target value of 5.5 bar. And the green curve is the wastegate diameter, and it's stable as well. So we have a stable result of 235.2 gram per kilowatt hour in fuel consumption and 302.9 kilowatts in power. Here is the Olshammar version, where we have added an extra exhaust cylinder, but we cannot do the simulation as the other simulations because we need the exhaust piston to move 50% faster than the combustion pistons in order for it to serve 3 combustion cylinders. So we cannot add a normal cylinder, but we have added a gear that is speeding up the crankshaft rotation by 50%, and that acts on a crank slider, and the crank slider acts on a volume that will simulate the extra exhaust cylinder, so to say. And here below you have the red text for the file that you can import from olshammar.com website, and check this yourself. And here are the parameters that we're optimizing in GT Power. And we have reached a stable pressure, and the fuel consumption is 225 gram per kilowatt hour, and the power is 322 kilowatts. So compared to the baseline engine, we have minus 4.34% in fuel consumption, and we have plus 6.3% in power. And here we can see the pressure graph. This is the pressure before the turbine. And the red baseline pressure curve is actually having higher peaks and goes to a lower value. So we can see that the blue line for the Olshammar version is the extra exhaust piston is actually smoothing out the curve here. If we would compare this with the 2+1 version of the Olshammar engine with the 2 combustion cylinders and 1 exhaust cylinder, then we had higher peaks, and we also had a much lower valley in between the peaks. You can see the scale to the left here, that it goes from 4 bar up to 7 bar. But for the 2+1 version, we reached almost 1 bar at the bottom peaks, so we have a much lower valleys there. And that pressure difference is very important when you have energy transfer to the exhaust piston. So there is not so much energy transfer to the exhaust piston because we have very little difference between the peak value and the bottom value here. So my analysis is that the Olshammar 3+1 version has a lower fuel consumption and more power than the 3-cylinder baseline engine, but it's not as good as the Olshammar 2+1 version. My thinking is that the Olshammar 3+1 version needs a side port. With the side port added, we can get a much lower pressure in the valleys in between, and that will allow us to have more back pressure from the turbine, and more back pressure from the turbine will allow us to increase the peak value of the pressure as well. So we will have a much higher pressure difference between the peak and the valley, and that will give us much more energy to the exhaust piston. But the question is, how can we simulate a side port with this crank slider setup? I'm not sure how that can be done. So if you have any idea, please import the model files and adjust them to add side port and see if you can improve these results. So you can download from olshammar.com the files you need. Thank you very much.